Good afternoon. How is everyone? We've got some good people. Everybody having fun? Show of hands, how many of you are new to Austin? How many of you tried the barbecue? How many of you like the barbecue? The real barbecue is in Kansas City. Go Chiefs! Thank you. I hear you, some of my fans. But we are here for something just as exciting as the Kansas City Chiefs. Certificates. So, I am honored to be here welcoming our Jamf team member from further away than most of us, Laurent. So I'm going to pass it to you, sir.
Thank you very much. Welcome, everyone. Thank you. So welcome here. Welcome people from all over the world, because I think we're live. Is that right? So good morning, good afternoon, whatever. So yeah, certificates. You all know everything about certificates, right? We can make a short session. Cool. So, as mentioned, my name is Laurent Pertois. I'm a senior professional services engineer at Jamf. Been working for Jamf for more than 8 years now, and I'm here to talk about certificate and tell you everything you wanted to know about certificate, almost. That would be a 4-day topic if we wanted to see everything, so I don't want to go that far. So we're going to talk about what they are, and also we're going to focus on how to use them with Jamf Pro and different methods to get these certs. I'm not going to cover all these methods again because short time. What is a certificate? Oh, no, sorry, that's the next one. So I put this quote because when it comes to certificates, it's like war. So you're going to hear a lot of horror stories from people who had to deal with certificates. I could tell you horror stories. But in the end, you're going to see, I'm going to try to show you that they are not that complicated. What is a certificate? Does anyone have a good idea? No? It's a way to prove an identity. And what is it based on? Oh, sorry, wrong click. Crypto. No, not this one. We're going to burn that one. No, it's based on cryptography. And cryptography is a lot of mathematics. Don't worry, I don't know any mathematics, so I'm not going to bother you with this. Just remember, it's a lot of calculation based on prime numbers. Another important part, PKI, it's what is delivering the certificates and what makes sure that these certificates are valid or revoked or whatever. So let's have a quick look at how we all use certificates daily, maybe without even knowing we're doing it. So on our one side, we have the apple.com website. On the left, we have our lovely computer. And we want to connect to the Apple website, and we want to make sure that we're connecting to the right website. Because it's so many cases, we're not sure. So let's go and establish a connection, and we're going to use the HTTPS protocol you've heard of. And we connect, and we say, hey, are you www.apple.com? Can you prove that to me? And in exchange, we're going to receive a certificate. It says, yeah, of course, look at it. It's written on paper. It's on a certificate. Then tell me, how do you know it's really the right certificate? Who proves you that this certificate is valid? Well, actually, Apple got that certificate from what is called a certification authority that is running a PKI. And that certification authority has also provided to our vendors, and in this case, Apple, the root CA, the public part of it, that is installed on your system, that is trusted by macOS. And based on that, you have something you know, something that is presented to you. You're going to be able to compare and say, okay, I see that this certificate from Apple is actually created by someone I trust. This someone I trust made it for Apple. I guess they do their due diligence to check that Apple was entitled to get that certificate. So they issued the certificate, so I'm going to trust what the website is saying. And if that sounds familiar, let me show you another example. On one side, we have a passport. I know it's a Peruvian passport for crazy reasons. If you want to know about, come to join me. But it's a valid example that I found on the internet that is not a creepy one. On the other side, we have a certificate. Let's compare them. Because when you go through, you travel abroad, for example, you show your passport, and someone is going to check and say, OK, is that the person, and so on. That's exactly what we do. And a passport and a certificate are very similar in many ways. So on a passport, you have your name. And guess what? On a certificate, you have your name. On a passport, you also have an issuer. Same for the certificate. That passport was issued by La República del Perú, and the certificate was issued by Digicert in that case. Another common thing, your passports have a validity period. They're only valid for a certain number of time, often 10 years. And the certificate, same thing. Oh, that one is expired, by the way. But very same. You have information that tells you this certificate is valid from that day to that day. If you receive that certificate after that date, you're not trusting it. And one more thing, like a passport, you have a serial number. So something that can be checked against what is called a PKI and other things. So you see, very similar. It's an identity thing. And when we talk about certificates, you may have heard of some terms like a hierarchy. So you have at the top the root certificate. That's the most important one when you run a PKI. That's the one you don't want to lose. Then you have an intermediate, and then you have the lift certificate, which is the final one, the one you're going to use really. In our example, that would be the www.apple.com. The intermediate is just here as an issuer, because you don't want to issue your certificate directly from your root CA. Your root CA is usually locked down, especially the private key of the root CA. You lock it down, no one can access it. You don't want to take it out of the vault unless you really have to. Your intermediate is the one who is going to issue the certificate. It's been signed by the root, so it's trusted. And if ever there is anything happening to the intermediate, you just revoke it, wipe it, create a new one. But you don't have to recreate your root CA, because your root CA is the one that is installed on every device. And if you had to recreate it, it means you have to go to see Apple, Microsoft, everyone, say, well, you know my root CA, you should remove it and put this new one, and then it requires updates and so on. Imagine the horror of it. Go on. So why do you want to use a certificate? Well, security. Nobody cares about security these days. So it's going to enhance security. Oh, okay. It's what's going to put the S in the HTTPS, but you can use it for many, many purposes. Probably more commonly in your case, you're going to use it to connect to the Wi-Fi, connect to the VPN. You may have heard of 802.1x, maybe? Rings a bell? But you can also use it for wired internet. Some people do that. Or to encrypt your emails. Simple way to do the encryption in that case. So, how do we deliver certificates with Jamf Pro? The simplest way, configuration profile. We script that, it's a nightmare, don't try to do it. Use a configuration profile, and you can deliver a lot of different certificates with that. Also, it pairs nicely with the Wi-Fi, because you can create a profile that will automatically connect to your Wi-Fi using 802.1x. It works both for macOS and iOS, tvOS, probably soon watchOS. And you can also insert other certs, not only the certificate that you're using to authenticate the device or the user. You can also add all the other certs. You remember that hierarchy I showed you, the root, the intermediate, and so on? You have to establish that chain of trust, so you can send that to your devices to be sure that they really trust anything coming from your PKI. So there are two kinds of certificates usually when we talk about certificates in Jamf. There are the user-based certificates and the device or machine certificate. You can see here, one has the name of a user, the other one has the name of a computer here. And when I say a user cert, I don't always mean that it's a user-level profile. The same way when I say a computer cert, it doesn't mean a computer cert. a computer profile, sorry. They are exchangeable. The user certificate is a certificate that is based on the name of the user. It doesn't have to be stored in the keychain of the user. Very, very well be stored in the system keychain. Same way, the computer cert, based on the name of the computer, and that also could be very well stored in the user keychain. So do not mix those, and your life will be much easier. So here you see we have a computer cert that is in the system keychain and a user cert that is in the user keychain. Guess what? You can exchange. Here you are. It doesn't matter. The question is that it has to be in a keychain and it has to be readable whenever you need it. Okay? Cool. Now, let's talk about how do we get certificates from our PKI onto our devices, on the Mac or iOS devices or whatever you manage. First, we're going to talk about SCEP, which is Simple Certificate Enrollment Protocol. And for those of you who were with me yesterday, I'm going to make the same joke. Whenever a protocol starts with simple, it's a lie. Think about SMTP. Well, actually, it used to be true a long time ago. So, for SCEP, we have many ways to do. We have many things to take care of this. We have a configuration profile we're going to use. And then we need to talk about the challenge, because, of course, we're going to talk to a server. And that server, we may not just go and say, hey, give me a certificate. And say, sure, whoever you are, I'm going to give you a certificate. No, it requires a bit of authentication. And for that, we have two cases: the static challenge, most common one, and the Microsoft Dynamic Challenge. This is the most common one if you use a Microsoft PKI. Okay. Let's start with the static challenge. So we have a configuration profile here, and we created, we're going to use the SCEP payload just here. Okay, I just showed the SCEP payload at the top for those who don't see my laser. And we're going to be asked to provide a few information, such as the address of the SCEP server, because obviously we need to know where to go, and a password, which is also called the challenge. And we need to also say we want a certificate, and we want that information in the certificate, the common name. And here we are using CN equal $computer name and other things after, based on what our best friend, our PKI admin, told us, or the network admin. So we create that configuration profile, and we're going to send it to our, oh, sorry, I had some little animations. Yeah, here we choose static. We put the challenge. Sorry for that, forgot. I don't speak too quick. Okay, what about the Microsoft Dynamic Challenge? So Microsoft SCEP implementation, also called NDES. If ever you see the name NDES, that means SCEP in Microsoft world. By default, they do not allow a static challenge. Static challenge means that everyone is using the same password. They don't do that by default. It can be done, but they don't like to do it, so let's ignore that. So instead, we're going to have to use a dynamic challenge. And for that, we have a special element in the SCEP payload inside Jamf Pro that says Dynamic Microsoft CA. And here you need a little bit more information, because you're going to need the address of what is called the admin page, and also a name and a password for an account that is allowed to access that admin page. Let me show you what the admin page looks like in real life when you go through a browser. Fancy? Welcome to 1992 HTML. You don't need more, I'll be honest. So when you connect to that very special URL, you authenticate with the account you were given, and you're going to be presented with a little bit of information, including the enrollment challenge password. That password is unique. You can use it once. After you've used once, it disappears. Can't use it anymore. If you go to that page and you just hit refresh in your browser, you will see that that challenge keeps changing. So the trick we have is that we need that information in order to get a certificate, and as you see, it changes every time. How do we solve that? Well, actually, Jamf Pro is going to connect to that page, map that page, find the challenge, and send that to the device as its static challenge, but it's unique to him, so to this device. Let's have a look. So here we have on top our lovely Jamf Pro server. At the bottom, we have a device, whatever it is. And on the side, we have a SCEP server from Microsoft, so an NDES server. And let's see how it works. So we've created the profile. We've put all the informations, the address of the server for SCEP, the address of the admin page to get this dynamic challenge. And we click Save. Of course, we scoped. And we click Saved. And this is what happens. Jamf Pro is going to connect to the admin page using the account we gave and going to retrieve the challenge. Once it has the challenge, it's going to put that challenge in the standard SCEP payload that is sent to the device as its password to use and send that to the device. And the device is going to read that and say, OK, I now need to go back to the NDES server, the SCEP server, and I need to authenticate with that challenge I was given. And as the challenge is good, the NDES server is happy. In return, we get what? A certificate. So that is great, but that means that any of your device needs to hit the SCEP server. And sometimes when you're going to tell that to your network admins, your security admins, whoever, they're going to be like, not a fan, unless you are already on the secure network. And like, yeah, but I need the certificate to get on the secure network. How do you want me to get that certificate before? So, OK, we need to find another solution. And for that, we have what is called a SCEP Proxy. Don't worry if you don't recognize that guy. It's a pure French reference. I'm sorry for that. And for those of you who know that guy, you get a bonus point. So let's see how we can use the SCEP Proxy, which is a feature including in Jamf Pro. The idea is that Jamf is going to act as the SCEP server. So in regards to the devices, when they're going to receive the SCEP payload, the address of the SCEP server is going to be Jamf Pro. Then in the back, Jamf Pro is going to go to the real SCEP server on our behalf. So if we go to Jamf Pro settings, PKI settings, then we have here an option to set Jamf Pro, to enable Jamf Pro as a SCEP proxy for configuration profiles. And you will recognize these fields. There is the URL for the SCEP server, and also the same choice between static and dynamic Microsoft CA, which is the one we're going to use. And again, the admin URL, the service account to get the challenge, the unique challenge. And we're going to need also a little bit more information because, again, you remember, we remember that page with the challenge? There is another bit above that is called a thumbprint for the CA certificate. And that thumbprint, you're going to need to copy it and paste it in the settings of Jamf Pro. Second step you need to do, remove the spaces. And you will also need to get a signing certificate. We have a lovely K-base in the Jamf documentation that explains you how to get that signing certificate, what is required. It's basically you need to ask your PKI admin to create a certificate for you. And that contains that and give you the certificate with its private key. And you will upload it to Jamf. The idea is that Jamf is going to, as we act as a proxy and a middleman for that acquisition, we're going to sign our request, going to say, yeah, it comes from someone you know. Now, let's go back to our configuration profile. It's going to look pretty similar, except you're going to check that box that says you want to use the settings that are in Jamf Pro settings. So you won't have to re-enter the URL and so on because it's already in the settings. But you will have to enter a subject, eventually what is called a subject alternate name. Welcome to French. We're international. So how is it going to work? Same actors here in that slide. Jamf Pro on top, device the bottom, and the server on the side. So first, we send the configuration profile to the device so that it thinks that the SCEP server is Jamf Pro. The device is going to create what is called a CSR, a certificate signing request. Basically, it's like filling a form that says, I want a certificate with that name and so on. It's going to send that to Jamf Pro, thinking it's the SCEP server. Jamf Pro is going to say, OK, hold on, man, my friend, I'm taking care of that. And it's going to go to our NDES server, get the challenge. Remember that, Microsoft Dynamics EA. Once we get the challenge, we can submit the request to the NDES server and say, OK, I would like a certificate. Based on that, this is my challenge to authenticate. I now also signed all the papers. You recognize the signing certificate. And in return, we get a certificate. And we can reply to the Apple device saying, hey, certificate, happy. That is great if you only need one kind of certificate. But if ever, for any reason, someone tells you, oh, well, we're going to use a certificate for Wi-Fi, but we also need to use a different certificate for VPN, then you're in trouble, because SCEP can only do one kind of certificate at a time. You will need to change all your settings every time. Not very, very easy. So we have another solution. If you are using Microsoft PKI, which is also known as ADCS, Active Directory Certificate Service, we created what is called a connector. Maybe some of you are already using it? Any hands? Anyone? Few hands, thank you. And tons of hands remotely. So the idea of the ADCS connector is that it's going to act as the requester of the certificate for us. Go to the ADCS or the real PKI and says, OK, I need a certificate with this information using that template, because that's what we need for the VPN. I'm going to need another one for the Wi-Fi, and so on. So how does it work? First, you need to install the ADCS connector. For that, there is a few prerequisites. First, you need a Windows Server 2016 or higher. 2016, 2019, 2022, all work. One thing, if you're using 2022, you would have to change one settings to say use TLS 1.2 and not 1.3, because it doesn't work otherwise. The second thing, this server needs to be a member of the same domain of the PKI is in, or in a domain that has a trust relationship with the other domain. I will show you that, don't worry. One more thing, you need .NET Framework 4.8. I think, someone might confirm, but I think only Windows 2022 comes with 4.8. Other versions, it's 4.5, so you need to upgrade. Be careful of that, because the installer doesn't check and doesn't tell you. I see some people nodding, oh yeah, we got it. Me too. One day I was in a rush testing something, didn't install 4.8, it went well, and then it failed. One more thing, a few more things you need also. You need a fully qualified domain name, FQDN. Because we're going to need to tell Jamf, you're going to connect to the ADCS connector with that name. And finally, there's a few ports that you need to take care of. By default, the ADCS connector runs on 443, standard for HTTPS. So you need to allow Jamf to connect to the connector using port 443. And the server who is hosting the ADCS connector itself is going to connect to the PKI using DCOM, DCOM, and that's no standard in Windows environments. And by default, it's using port 135 and a big range from 49,152 up to 65,535. Microsoft has documentation about how to change that. And we stay in a Microsoft environment because it's a Windows server that talks to another Windows server. Doesn't involve Jamf. It works. OK, let's have a quick look at how it works, the communication. So Jamf is going to talk to the ADCS connector using HTTPS, as I said. We'll look at how it does the authentication. And once it's authenticated, the request is sent from the Windows server. And I insist when I say Windows server, it's no longer the ADCS connector who does that request. We're really using the Windows services to do that. And to talk to the PKI server over DCOM, get the certificate. Once we get it, Jamf comes back and say, yep, I'll take it. That's my job. Again, as I said, simple setup. Here in our case, ADCS connector on the right, PKI on the left. They're both members of the same domain. Everyone is happy. It works perfectly. Later on, I will show you some more complex setup. When you install the ADCS connector, it's a PowerShell script. You've seen that if you've tried or looked at the documentation. And it requires a few information when you install it. So the script is called deploy.ps1. Then it asks you for the FQDN of your ADCS connector. So if your ADCS connector is directly reachable from internet, you need to give it its real public name. So in my case, it's adcsc.example.com. Then there is a second switch that says Jamf Pro DN. Here it says foo.jamfcloud.com because that's the name of my Jamf Pro server. Little secret. You can put whatever you want in that field. It doesn't matter. I'll show you why later. Only the second one. The first one, no. The second one, the Jamf Pro DN, matter. And then you need to tell it install IIS, configure HTTPS, do a clean install, standard. You have this command line in our documentation. You can simply copy it, edit a little bit, and paste it in your PowerShell command line tool. So this is what it looks like. If everything goes well, it's going to spit out a lot of information. Make sure of one thing. Once it's done, you need that final line, the line that says, note, client cert key store password, blah, 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 blah. You want to copy that and save it for later. I recommend copy everything. But don't close your your PowerShell window before you made sure you saved that. If you didn't save it, you can start again. So at the end, you will see in the folder that contains the ADCS connector installer, you will see two more files, one called adcs-proxy-ca.cer, and the other one, client-cert.pfx. These two certificates, you're going to need them to set up Jamf Pro. So let's go to Jamf Pro. We go to Settings, PKI Settings, and we're going to click to Configure New Certificate Authority. We'll be presented with a choice. Our choice is Active Directory Certificate Service, ADCS. And then we're going to put a few informations. At the top, we're going to put the fully qualified domain name of the PKI server. It's going to be an internal name. It doesn't matter because remember who is connecting to the PKI server? Your Windows server hosting the ADCS connector. So even if it's an internal name, you're like, oh, but Jamf Pro can't reach that. We don't care. Jamf Pro will never talk to that server. Only the server hosting your ADCS connector is going to talk to it. Then the name of your CA, something you need to get from your PKI admin. And finally, URL or IP address, the FQDN of your ADCS connector. I know it says IP address, don't use. Names. Then we need to upload the two files we got from the installer. The first one is for the server certificate. So you're going to choose the one that ends with .cer, so ADCS proxy ca.cer. Easy. And then the second one is called the client certificate, and it will be the second one, the client certificate.pfx. And this is where you're going to need the password that we had a few slides before, and I told you you have to copy and save. Because that certificate is protected with that password. You lost it? Go back to step one. Okay, type the password, upload, and voila. You have an ADCS connector now. Click Save, of course. A few more things. As I said, with ADCS connector, we have a lot more flexibility because instead of a single template, a single kind of certificate, we can have as many as we want. So you may have to work with your PKI admin so that it creates a template for you, or all the templates you need, or maybe we can use some existing ones, but be very careful. I'm going to show you why. sometimes it won't work. The very important things, 2, subject name must be set to supply in request. It's not set to that. The other option is use the name of the requester. That means all your certificates will have the same name, the name of your server that is hosting the ADCS connector, because it's the one requesting. Second thing, in terms of access to the template, your connector server needs to be able to read and enroll. I will show you that, don't worry. So, that's on the Windows side. That's the job of your PKI admin, but you can help me maybe. So we need to go to our certificate authority application, also called cert SRV. And we're going to look at the certificate template, do a right click and click on Manage. And when we click on Manage, that opens a new window, which is the Certificate Template Manager. And we're going to pick an existing template and have a look at it or duplicate it. Most of the time we duplicate it. And we double click on it, and this is what it looks like. We go to one of the multiple tabs called Subject Name, and we make sure to choose Supply in the request. If it says Build from Active Directory information, wrong. Unless you want all your certs to be named the same, but usually not the case. Be sure that we have Supply in the request. Second tab where we go, Security. And here in Security, we're going to make sure we click Add and select the name of our server hosting the ADCS connector, add it, and click and check 2 boxes. In the Allow column, we want Read and Enroll. You may only have Enroll in your case. That's because all authenticated users already have Read. I like to check the 2 boxes because it happened to a customer. We only checked Enroll, worked for a while, suddenly it stopped working. What's wrong? We didn't change anything. Well, actually, someone came and removed the authenticated user's read. So basically, our server could only enroll. It was not enough. So check, read, enroll. You make sure that you're safe for the future. Another thing you're going to need in the General tab, that template has 2 names. The display name at the top and the template name below. In Jamf, we're going to need to say we want to use this template. We need to name it. We want to use the second name. Easy to recognize, no spaces. Okay? See the first one, there are a few spaces in the name. The second one, all the spaces have been removed. That's the name you want, the template name, not the template display name. Usually they're the same, but with spaces on. Good. One more thing. That template needs to be published. Because it's one thing to create a template in the template manager, but if you don't publish it, the PKI says, I don't know what you're talking about. I don't have a template with that name. So it needs to be published, which once again is in the certificate authority, right-click, new, certificate template to issue, pick the right one, click OK, boom, we're done. All right? OK. A few months ago, we introduced version 1.1 of the ADCS connector, and one of the big features added is the ability to revoke certificates. So I didn't really talk about that, but when you create a certificate, it has a validity. And at any time, we can tell the PKI, you know what, we no longer use this certificate. We're going to revoke it. And in the process of checking if a certificate is valid or not, we can check if the PKI says it's still active. If it's been revoked, the PKI will say, OK, yeah, it's technically valid until next year, but it's been revoked. Don't use that certificate anymore. Don't trust it. And with version 1.1, we introduced that, which means that, for example, you push a configuration profile to a device, and then for whatever reasons, you decide to remove that configuration profile from that device, which removes everything, including the certificate. And at the same time, Jamf will issue a command to the ADCS connector and then to the PKI to say, we want to revoke that certificate. It's no longer trusted. It means that your infrastructure, for example, your radius for the Wi-Fi, will no longer trust that certificate. So in order to do that, we need to add an extra information, which is in the certificate server. That's something your PKI admin needs to do. You can't do it, probably. We're going to go to the cert SRV, the cert administrator, right-click on the CA itself and just properties and security. We're going to give the server hosting the ADCS connector a few more privileges, which is issue and manage certificates. It looks like this. So at the top, we see IT42 issuing CA1. That's my CA. I right-clicked, add properties, went to security, added my server, and I said issue and manage certificate, allow. Okay. And in Jamf Pro, go back to the PKI settings, click on view details for your ADCS connector, and check the box that says automatic certificate revocation. And that's it. Now, we have this wonderful ADCS connector. How do we issue certificate to our devices based on that? Configuration profile. Yay! I told you, everything is a configuration profile. We go to certificate this time. We don't use SCEP, we don't use anything else. We go to certificate and click to new. And in the menu where we choose where we get the certificate, usually you only have upload. Here you will see a new item that is the name of your CA. For example, in this case, company CA. That tells Jamf, use the settings that you have in PKI settings for the ADCS connector. And then after that, more fields where we can put the certificate subject, the name, the subject alternative name, a very common request these days. So again, something to check with your network admin and so on. And at the bottom, the template name. Remember, template name, not template display name, the one without spaces. And of course, you can choose to allow or not export from keychain. Usually you don't. Allow or not allow all apps access. So, how is it going to work? In more details. That's very important. You will see later why. We have our Jamf Pro server, the ADCS connector in the middle, the PKI in the back. First, Jamf Pro connects to the ADCS connector and checks the identity. www.apple.com, remember this earlier? And we compare the certificate we got from the ADCS connector with the one you uploaded at server certificate. They do match, happy. They don't match, we don't go further. Then we send our client certificate for the authentication. Hey, it's me, you can trust me. ADCS is going to compare. Yes, that's the one I created during the installation. We can go on. Then we request the certificate. The ADCS connector is going to go to the PKI, use Kerberos to authenticate using the server account. And as the PKI is happy with that authentication, we're going to get a certificate. Now, of course, your security is going to say, well, I don't like you to put the ADCS connector directly on the internet. I would like to put something in front of it, because that's what we do, and I would say, why not? So, most common one is either a reverse proxy or load balancer, more or less the same thing. But if you remember the way I told you it works, you may think, it's going to break. And you're right. Because what's going to happen? Jamf Pro is going to connect to that load balancer thinking it's the ADCS connector. But if you don't change any of the settings anywhere, first time it's going to connect to the ADCS connector, well, the load balancer is going to receive a certificate, the identity certificate of the load balancer, compare it to the one you created with the connector, and say, that doesn't match. They're not the same. I don't go further. Even if it's a very valid certificate, they need to match. So it's important that on the load balancer, we install that very same certificate. Or if you use another one, because your admin says, no, I'm not going to install your self-signed certificates, I don't want that, then in Jamf Pro, you're not going to upload the server certificate that was created by the connector, but the one that is used by the load balancer and that your admin is going to give you. Remember, it's the public part of it. Anyone can have it, no problem. Okay? Same for the authentication. Jamf Pro is going to try to authenticate using the client cert to the load balancer. If the load balancer doesn't know to do anything with that, Jamf Pro will say, I was not authenticated, not anymore. I'm not going anywhere. So in a world where everything is set up correctly, this is how it works. Connect, check the certificate, identity matches with the one we have. Happy, we can go next step. We authenticate with our client cert. The load balancer says, yeah, I know that client certificate. You're authenticated. Now it's my job to go to the ADCS connector. And ADCS connector, we're going to authenticate with the very same certificate that was created. So your load balancer needs to be set up also to authenticate with the ADCS connector. That can be tricky. But if you talk to the right people, it works. And then we go further, get the certificate, always the same, Kerberos authentication. So the very important part of that, you put something between Jamf Pro and ADCS connector, you need to set it up as if it was the connector in terms of authentication and certificates. Now, some more advanced setup. I had a customer who said, well, not only do we need different templates, but also they are issued by 2 different PKI servers. How can it work? Do we need a second ADCS connector? You can guess on this screen? No. What you're going to need to do is create a second ADCS connector entry in the PKI settings. Because go back a few minutes ago, so we click to create a new one. The first line is the address of the PKI server, the one the connector is going to talk to. So we just create a new entry, give the name of the new PKI server, the name of the PKI itself, same name for the address of the connector, and the same certificates. You don't relaunch the installer, you don't create new certificates, you reuse the same. Same server certificate, same client certificate, because we talk to the very same client, to the very same ADCS connector, so we don't need to redo anything. It's just in the background that we talk to a different PKI server, but that's the job of the connector, not the job of Jamf Pro. Now we have 2 entries, which means that when we create a configuration profile, we can choose which one we want to use. Again, templates, blah, 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 blah. Other advanced setups. One of my customers says, well, as we're going to put the ADCS connector in the DMZ, we can't put it in the same domain as the PKI, because we don't use that domain in the DMZ. We have a different domain for the DMZ. Well, I'm fine with that, but do you have a trust relationship between these 2 domains? Same for REST, Windows. Do they trust each other? Yes. Perfect. It works. Just to check, it's in the it's a Windows tool, Active Directory domains and trust, and you can check the properties between the 2 domains. You will see the 2 domains. You can check the properties and check that each one trusts the other one. Something that your Windows admin should be able to care to handle. Don't need to know that. Same properties for the second domain. Do I trust the first one? Yes. Everyone is happy. All right? Another case I had, my case, actually, to start with. I have 2 Jamf Pro servers. I have my production server and I have my test server. Do I need 2 ADCS connector? No. Same way. We're going to set up the first one, upload the server certificate from ADCS connector, upload the client certificate from ADCS connector, set it up, everything's happy. On the second server, upload the same files. And that's why I said, if you remember at the beginning, the Jamf Pro DN in the installer, it doesn't matter. There's no tie between the connector and Jamf Pro. Basically, the connector knows nothing of Jamf Pro. It knows one thing: the client used to authenticate, the certificate used to authenticate. That's it. And you can go crazy. Of course. And even more crazy. No, we'll stop here. But you can go very crazy. I have war stories about that. But yeah, that would mean 2 PKI settings in the first Jamf Pro server, 2 PKI settings in the second Jamf Pro server, and every time we reuse the same server certificate, the same client certificate. If you had a Jamf Pro, an ADCS connector that was from version 1.0, the very original version we published, how do you upgrade to 1.1 to have the revocation? That's the only reason to upgrade, to be honest. A few things to be aware of. You need to make sure that you update your .NET framework to 4.8. And I insist, it's the .NET framework, not the full .NET. Big difference in terms of size. Then do a little backup of the installation. It's by default in C, inetpub, www root, ADCS proxy. Just do a copy of that folder. Then download the installer for 1.1. Unzip it, unzip the adcs.zip that is inside, place the content in replacement of the other, and restart IIS, and you're good to go. Troubleshooting. Well, first step of troubleshooting, checking if everything is fine or not. My go-to whenever I try to get a certificate is always I look in the IIS logs on the Windows server that is hosting my connector. Do I see any connections from Jamf Pro? If everything is fine, you will see 2 lines with that goes to /API/v1/certificate/request, and the second one to retrieve. They will be starting with post. You will see the IP address of your Jamf Pro server, or maybe there's a firewall in the middle. Doesn't really matter, but it should say 200. 200 in HTTP world is everything is fine. And it's only 2 lines. Those who remember my presentation from a few years ago in version 1, there were 3 lines. We changed that. It's on the Jamf Pro side. We don't check the version anymore for whatever reason. It's only 2 lines, 2 post, request, and retrieve. If we see something else, we may see an error. So we may see nothing. In that case, that means that we don't go to the connector, check whatever is between Jamf Pro and the connector. Something is blocking. If we see a 403.16 error, you see in that long line, 403.16, this is a quite common error on IIS. It's a well-known error from Microsoft. It means that someone has inserted a root certificate into the intermediate certificate store on Windows. Just tell that to your Windows admin, he should understand. And if ever, you can have him run 2 command lines like this in PowerShell, one to get the list, the second one to remove them. It might come back, because it might be a GPO that is pushing these in the wrong place. If it's going to come back, it's going to break it again. I'd have to do a bit more work to make sure that it does not come back. Other common issues. Server can find the template, check the security on the template, make sure you have read and enroll. Again, it might be that authenticated users give you read, but if it's removed and you only add enroll, it's going to fail. ADCS connector requires a proper FQDN. If you try to use an IP, it will fail. I tried many, many times. Don't trust what we say in the GUI. Do not break the authentication. Remember when I was playing all the steps with the load balancer in the middle, I had to authenticate with the load balancer, and then the load balancer had to authenticate with the IIS. That's what I call replay the authentication. If you break the authentication, if the server is not, especially if it's inspecting the content, even if it tries to be transparent but just inspecting the content, it will strip this client certificate. And IIS will say, you're not authenticated, I don't want you here. So always, step by step, check that every step, nothing is broken. I've seen GPOs could block authentication because security settings. Template is not published. I did that, so I'm not proud. And finally, another common version, especially now with 1.1, wrong .NET version. You upgrade to the 1.1, you'd forget that prerequisites of making sure you have .NET Framework 4.8. You try, it fails miserably. On that note, thank you for listening. Hope I didn't lose anyone. And thank you. And we may have a few questions.
And thank you all. I know we are a few minutes over, so thank you for sticking with us. I'm
Sorry.
just going to...
It's me.
He told me he was going to run long. But great information. I am going to address one or two questions. So first question is, we're using an ADCS connector to get user authentication certificates from an on-prem Active Directory certificate service server.
Yep.
We then distribute the certificates using a user level profile. Mm-hmm. We'd like to stop using the ADCS connector and obtain them via Azure App or Azure Web Proxy. Are there any Azure hosted solutions available for this purpose which Jamf Pro supports connecting to?
So if I understand correctly, they want to remove their ADCS on-prem to move it to Azure. I have a customer who is hosting their ADCS in Azure. I don't know if that would answer that question. One thing to know, I didn't mention, sorry. You can't put ADCS connector behind an Azure Web Proxy, Azure App Proxy, because that does not work with certificate authentication. So be careful of that. It basically fails.
All right, we will grab one more and then feel free to stay after if you'd like. We can connect. What is the...
If you don't mind.
Please.
I have a brain dead tomorrow open if you want to come meet me. It's at 11 at the Brain Dead Lounge. Feel free to come. And I'll be at the party tonight, but don't promise answers.
What if the PKI cert is not removed when the config profile is removed from a client? Example, in testing, I have multiple copies in keychain. Unexpected.
So one of the PKI cert is not removed. Depends on which certificates. That's a question. It may be that there are more than one profile that pushes these certificates, and until the last profile that has the certificate, it will not be removed from the keychain. If it's the certificate for the machine, it should be removed. If it's not, we need to ask to open a ticket with support, I guess.
All right, with that, I know there are a few more questions we were unable to address. Again, please join him tomorrow for a brain date.
Yeah.
Look for him at the party. We hope to see you all there, and we will make some comments here as well. Thank you all for your attendance, and have a great evening.
Thank you very much. Enjoy the party tonight. Thanks for joining me.